Good morning, chemistry students. Here are your Chapter 9, Day 3 notes. We're going to finish up Chapter 9, Section 2 about stoichiometric calculations. Remember, we have previously talked about mass calculations, and you added a mole ratio to your chemistry toolkit. Again, please make sure you have your calculator out, your periodic table out, and your chemistry toolkit index card out and handy as we go through and take these notes. So, in addition to a mass calculation, there are many other stoichiometric calculations, and there are many different types of problems. There can be mole, so that means you're given to start with is in moles, and your product or what you're asked for is in moles. Mass, so given grams, asked to convert to grams. Mass, volume, so given grams, asked to convert it to liters. Volume, so given liters, asked to convert it to liters. Particle, mass, so given some number of particles, asked to convert to mass. The trick to doing all of these is that you must choose which conversion factor and I'm going to kind of put an S on it because for many of these you'll have to use more than one to use. And that's why, again, especially when you're new at doing these, having that chemistry toolkit sitting right next to you as you do the problems can be very helpful. The other important thing to remember about this is the fact that the only way to go from one substance to another, so to a different substance, is using a mole ratio. From a balanced chemical equation. So, again, that's why all of those tools that are on your toolkit that you had from Chapter 7, they all have moles in them. Okay? And the only way to go from one substance to another is to use that mole ratio conversion factor that you've added to your toolkit that has some number of moles of A to some number of moles of B, where A and B are different substances. Again, remember, these numbers come from your coefficients of your balanced equation. So we're going to look at a couple examples here. Our first example, ammonia reacts with oxygen to produce nitrogen monoxide and water. How many liters of nitrogen monoxide are produced when 1.40 liters of oxygen reacts with ammonia? Again, one of the things that all of these stoichiometric problems have in common is that you first need a balanced chemical equation. So again, if you still need to do a word equation and then a balanced equation, that's fine. I'm not going to do the word equations any longer. So we have ammonia, which is NH3, reacts with oxygen, which has to be O2 because it's part of Dr. Brinkelhoff, to produce nitrogen monoxide. That's a molecular compound, so my prefixes become my subscripts, so it's going to be NO. and water, which is H2O. So now I need to balance this. I have 1 nitrogen and 1 nitrogen. I have 3 hydrogens on the left and 2 hydrogens on the right, so I'm going to make that 6. So now I have 2 nitrogens, so I need a coefficient of 2. And I have 2, 3, 4, 5 oxygens. So I'm going to try that little trick from combustion reactions, and when I need that odd number, I'm going to put that odd number over 2 and then multiply through by 4. So this 2 is now going to be a 4. This 5 over 2 is now going to just be a 5. This 2 is now going to be a 4. And this 3 is now going to be a 6. So now I'm going to check it. I have 4 nitrogens, 12, 4 times 3, 12 hydrogens, 6 times 2, 12 hydrogens, 10 oxygens, 4 plus 6 more makes 10 oxygens, and so that is my correctly balanced chemical equation. Now, again, I like to summarize the information from the problem so I don't have to keep going back and looking at it. So it wants to know how many liters of nitrogen monoxide are produced when 1.40 liters of oxygen reacts with ammonia. So again, this is asking me to start with my 1.40 liters of oxygen and convert that to liters. So again, I start with my given, which is 1.40 liters of oxygen. On my toolkit, liters of oxygen can be converted to moles of oxygen using my tool of molar volume. Moles of oxygen, I'm going to use my mole ratio now to go to my moles of my other substance, which is nitrogen monoxide. Moles of nitrogen monoxide, I need to take it back to volume, so liters of nitrogen monoxide, using my molar volume again. Again, when I look at my toolkit, right, this is molar volume, this is my mole ratio, and this is molar volume again. So my molar volume is always 22.4 liters to 1 mole. 1 mole, 22.4 liters. Now, I can be smart when I put this in my calculator, right? Because I have 22.4 in the numerator and 22.4 in the denominator, which means they're going to cancel out. My mole ratio, my numbers come from my coefficients. So my coefficient on nitrogen monoxide is 4, and on oxygen it's 5. So because I recognize that these are going to cross out, effectively on my calculator I can do 1.40 times 4 and take that answer and divide it by 5. So 1.4 times 4 divided by 5 gives me 1.12, and I want 3 significant figures, so I'm going to use 1.12 liters of nitrogen monoxide gas is what I produce. So again, this was a volume problem, and we used molar volume to convert liters to moles, a mole ratio to convert from one substance to another, and then molar volume again to convert moles back to liters. We'll look at a second example. Ammonia reacts with oxygen to produce nitrogen monoxide and water. Again, we need a balanced chemical equation. We already did this once, so we don't kind of need to go through this a second time. It was for ammonia reacting with 5 oxygen to produce 4 nitrogen monoxides and 6 waters. And so this one says how many molecules of ammonia are needed to react with 1.40 liters of oxygen. So this would be a volume particle one. So again, I start with my given, which is my 1.40 liters of oxygen. Again, I'm going to use molar volume to convert liters of oxygen to moles of oxygen. Again, now I can go from one substance to another, so I'm going to go from moles of oxygen to moles of ammonia. That's my mole ratio. And this was my molar volume. Now I'm in moles of ammonia. I want molecules, so I have a tool on my toolkit that relates that. So moles of ammonia goes on the bottom. Molecules of ammonia goes on the top. And this is my Avogadro's number, my count conversion factor. So now, again, I like to do all my tools or my conversion factors first with their units, and then I like to come back and fill in numbers. Molar volume, it's 1 in front of moles and 22.4 in front of liters. For my mole ratio, my numbers come from my coefficient. So my coefficient on ammonia is 4, and on oxygen it's 5. For Avogadro's number, for my counts, it's 1 mole, and it's 6.022 times 10 to the 23rd. So, again, on my calculator, I'm going to do 1.4 times 4 times 6.022. I'm going to use that E button, 23, divided by, have to use parentheses because I have more than one thing I want to divide by, times my 5. So 1.4 times my 4 times my Avogadro's number divided by my 22.4 times my 5. And again, I want to have 3 significant figures. So my calculator gives me 3.011 times 10 to the 22nd. So I'm going to write that as 3.01 times 10 to the 22nd. And this is molecules of ammonia. So again, this is the kind of work that I expect to see for your homework. So to do any of these stoichiometric problems, you just have to choose what tool of your chemistry toolkit to use. So your homework is on page 250 to do questions 19 through 22. Again, you need to show all your work, just like the problems that we just did in your notes. Okay, and you're not going to type this because, again, it's a pain in the butt to type this out. So I just want you to hand write it out and then take a scan of it with your Adobe Scan app or take a picture of it to upload. Have a great day. Good luck on your homework. I'll talk to you tomorrow.